Probability is the study of what is the likelihood of something happening. So when we want to calculate the probability of an event, really what you want to know is it's got this formula right here, but here's what this formula means. Is basically what I want to do is I want to take the number of events that can happen not that that can happen. I want to take the number of events that I want to happen, which ones make me happy, versus the ones that can happen, everything that can happen. Now, a couple of things that you need to know. Coins have two sides. Dice, if I say we're going to roll a dice, I typically mean a six-sided dice where you can get a 1, a 2, a 3, a 4, a 5, or a 6. A coin, we're going to always think heads or tails. And then your standard deck of playing cards, you have 52 different cards. There are 4 different suits: hearts, diamonds, spades, and clubs. And then you have 26 black and 26 red, and then you have 12 face cards, 3 in each suit. To be a face card, it has to have a face. A jack, a queen, or a king has a face. An ace doesn't have a face. So let's talk first about what is theoretical versus experimental probability. So experimental properties. So say that you roll a dice. Or you flip a coin, that'll be easier. Say you flip a coin 10 times. Well, we know that what should happen, which is theoretical probability, what should happen is that you should get heads half the time and tails half the time because you have 2 possibilities. So, and they're equally likely. So we know that you have a 50-50 chance. You can write this as in 3 different ways. You can write it as a fractional probability, 1/2, a decimal probability, which is 0.5, or a percent probability, which is 50%, where you move the decimal 2 places to the right. So we have equal likelihood of flipping a heads or a tails experimentally. Now, if we were to do an experiment and have the entire classroom just start flipping coins and keeping track, what we're going to find is it's not always half and half. What actually happens is our experimental probability. What happened when we experimented? Did it actually happen the way that it should, or did it happen in a different way? So, for example, you might toss a coin 10 times and you get 3 heads and 7 tails. Well, then your experimental probability would be 3 out of 10, or 0.3 or 30%, and your probability of tails would be 7 out of 10, 0.7 or 70%. So experimentally, it appears that you were more likely to get tails than heads, but we know theoretically that you should have gotten 50-50. Now, what's going to happen is if we do it 10 times, you might get 3 and 7. But if you do it 100 times, it's going to get closer and closer. So the more times you do it, the more your probability is going to get closer to 50%. So you need more opportunities to flip the coin or roll the dice to make your experimental match your theoretical. So let's look at some probabilities. So remember, what we're looking for is what makes us happy, what we want, over what are the situations that can happen. So a marble is drawn from a bag that contains 4 blue marbles, 6 green marbles, and 3 yellow marbles. So that means I have 13 marbles in all. So that's what can happen, okay? I can choose 13 marbles. So I put them in a bag. What's the probability of drawing a green marble? So it's going to look like this, P with green in parentheses. That means the probability of drawing a green marble. So I look at my data. I have 6 green marbles. So 6 green marbles are what I want. So I can choose, I want 6 of the green marbles out of the 13 marbles that I could pick. Okay, so that is my reduced fractional probability. Then I can change that to decimal probability, 0.462, and I can then convert that to my percentage probability, which would be 46.2%. Move the decimal 2 places to the right. Okay, what's the probability of drawing a yellow marble? Well, let's see how many yellow marbles we have. We have 3 yellow marbles, so 3 yellow marbles make me happy. And then there are 13 marbles in the bag. Again, that's my fractional. We always reduce. 3 over 13 doesn't reduce. That gives me 0.231 or 23.1%. I find that percentages are often more understandable for students, particularly because you're used to grades being in 100%. And so they're a little bit easier for you to understand than 3 out of 13. So basically 3 out of 13, what that means is if I were to do it 13 times, I should only draw a yellow marble 3 out of 13 times. Okay, that's what that means. So what's the probability of rolling a die and getting a 3? Well, remember, we can roll a 1, a 2, a 3, a 4, a 5, or a 6. So what's the probability of getting a 3? Well, there is 1 3, and there are 6 possibilities. Okay, so there's 1 3, and there are 6 possibilities. So that's 1/6, which in percent would be 16.7%. What's the probability of rolling an odd number? Well, an odd number, 1 and 3 and 5, those are odd numbers. So there are 3 odd numbers out of 6 total numbers on the dice. So I have a 50% chance of rolling an odd number, or for that matter, an even number. Something other than a 1. So I want to pick anything other than a 1. Well, I could do a 2, a 3, a 4, a 5, or a 6. So there are 5 numbers that are something other than a 1. 5 make me happy out of the 6 things that can happen. And so that is 83.3%. So you'll answer depending on how you are told to answer and watch for your rounding errors. So you're playing a game in which you roll 2 dice simultaneously. What is the probability that you will roll a 10? So here we have all of our possible outcomes, and so we want to go through and find all of our 10s. So we need, our easiest one is 5 and 5, and then we've got our 4 and 6 and our 4 and 6 here. So there are 36 possible outcomes when you're rolling 2 dice. Okay, there are 36 things that can happen. So of those 36, 3 of those 36 make me happy. Now, if I ask you to give it to me in reduced fraction form, then you would need to reduce that to 1/12. If I ask you to give me the answer in decimal form, then you would say 0.083, and you would round it to whatever decimal that you're told to round it to. Or if I ask for in percent form, then you would move the decimal 2 places, and you would do 8.3%. I like to do 3 decimals, like to do 3 here to the nearest thousandth, and then that way you have enough where you can have 1 decimal place for when you move it with percentages. Okay, given a full deck of cards, what's the probability of drawing a face card? Well, if you remember back, if you need to look back at the front, there are 12 face cards. 12 face cards make me happy out of the 52 cards that there are. If I reduce that, then that gives me 3 out of 13. Okay, so if you convert that to decimal, it's 0.231 or 23.1%. What is the probability of getting a red card? Well, there are 26 red cards out of the 52 cards, so I have a 0.5 or 50% chance of drawing a red card. So this is a Venn diagram. Let me just remind you how a Venn diagram works. The ones here and the 11, those are the people that are only taking sociology. The 18 are they're only taking philosophy. These 12 are taking both. They're taking sociology and philosophy. And then I have 9 down here that aren't taking either one. And there are 50 students in the class. So how many take sociology? Now, they're taking sociology, period, right? It doesn't matter whether they're taking anything else. So there are 23 that are taking sociology. So 23 out of 50, which is 46%, are taking sociology. So almost half of the students are taking sociology. What's the probability that you're going to choose a student? You've got 50 people in the room. What's the probability that you're going to choose someone who takes both philosophy and sociology? Well, there were 12 that were taking both. Okay, those were the ones here in the middle. There were 12 out of 50 that were taking both. We always reduce that on our fractional percentage or our fractional probabilities, and that gives you 24%. So almost 1/4 of the students are taking both. How many are taking sociology but not taking philosophy? That's where we want this 11. 11 of the 50 are only taking sociology. Okay, 11 out of 50 is reduced, or that is 22%. And then what's the probability of choosing someone who is not taking sociology or philosophy? So that would be the 9 people of 50 people are not taking either one, which is 18%. So really what's the important part is this right here. Probability comes down to the events that I want, the number of events that I want to happen over the number of events that are possible that can happen.